we will start control statements. So in C programming language, the different conditional statements that we have, right? Programming language. So we'll see one after the other. We'll see if statement first. It is used as it executes a block of instructions when the condition is true, right? When the condition is true. The syntax of if statement: if followed by parenthesis. Within parenthesis, you will be having some condition to be checked, right? Then close parenthesis, you will have the block of instructions followed by the same. You can have some set of instructions here, okay? This is said to be the if block here, okay? So the condition is going to be checked here. If the condition is true, then you will be allowed to execute this if block. Okay, then you come on to the next statement. These are the next statements. If the condition is false, you are not allowed to go inside this. You will be directly coming on to the next statement. Okay, this is how the if statement working procedure is. Now we'll see the syntax diagram of the same, right? Syntax diagram of if statement. Okay. So what happens here? You have a condition. Conditions are going to be represented through diamond, right? So when the condition is true, if block is executed, right? Then you will be executing the next statements. So this is the syntax diagram of if statement, right? Fine. You have a condition. Condition is going to be represented with the help of a diamond box or rhombus or diamond, you call it as, right? So this condition is going to be tested. If the condition is found to be true, then you will be allowed to execute the block. Then you will be executing the next statement. But if the condition is false, you will directly execute the next statement. Okay. Now we'll demonstrate this with the help of few examples. Okay. We'll write some programs here based on this. Write a program to find the entered number is odd or even. Okay. How do you find the number is odd or even? You divide it with 2 and then check the remainder. If the remainder is 0, then you say even, right? If the remainder is 1, you say it is odd. Yes or no? So for example, 4. Whether it is odd or even, how do you know? You divide it with 2. 2 to the 4, right? So what is the remainder you get? Remainder you get 0, right? So if the remainder is 0, you say it is even. For example, 5, right? you divide it with 2, and if the remainder is 1, you say it is odd. Yes or no? So now we'll try to write the program here to find the number whether it is odd or even. So how do you do that? You start with main, okay, main open braces. Then here I'm taking a number. Let us say a number is n, and the remainder I wanted to hold it in. Let us say r. Okay. First, you have to accept the number from the user. The user is going to input through keyboard. So how do we read with the help of scanf statement? So we will be having printf, enter the number. We will read it through scanf, right? Percentage D ampersand N, right? Now you will be dividing N with 2, and then the remainder has to be, after having been obtained, has to be checked, right? So N mod 2. You are saying R equal to N mod 2. It means N will be divided with 2 and the remainder will be available in R. So this R value has to be checked, okay? So if R value is equal to 0, this is a comparison operator. Double equals is the comparison operator. This comes under relational operator, right? When you are trying to compare or relate two values, you can use the relation operator. So here, this comparison we are using, right? Equal comparison we are using. R equal to 0. If R equal to 0 is true, then what happens? You want to print the number is even, right? Printf, you say the number is even, okay? Close this if brace, you can close here also. Then you can have another condition, because you have another condition to be checked, that is if R equal to 1. Okay, you can say R equal to 1 or R not equal to 0, both are same. Yes or no? Whether you say R equal to 1 or you say R not equal to 0, both are same, right? So I can check with either of the conditions. Fine. If R is not equal to 0, then what you are saying? It means R must be 1 when the number is odd. So what is that I'm saying? The number is odd. Then close the if brace, then close the main function. That's it, right? This is the end of main. Okay. Now you can see the program. Here in this program, we have declared two variables, n and r, and we have accepted a value in n, for which we wanted to check this program. Okay. So this number which we have accepted from the keyboard is whether odd or not, odd or even. So for that logic is you have to divide it with 2, and then the remainder which you get out of it, which you are holding it in R, you are checking. If the R value is 0, you say it is even. If R is not equal to 0, then you say it is odd. So I hope this is clear to all of you. Just go to online GDP first, say login here, just say Google Plus. Okay, so you will be logged in, right? Now, I think if I have that project available in my project, I will directly take it from there. We'll check whether it is available, odd even program, or else I'll write it, okay? Fine, I don't think it is available here. So for that, for a new project to be created, what we say, create new project. And then here we're going to write the code, right? So what is the code here required to be written? We need two variables. n comma r. Okay. Then enter the number. How do you accept the number? Using scanf, right? Scanf. It is an integer, so format specifier must be percentage %d, comma ampersand n, right? So yes, then you are going to divide n with 2 and obtain the remainder out of it, which you are storing it in R. Now you are going to check this R, whether it is equal to 0, right? If I have a single statement, I need not to have a brace also. I can straight away write the statement, okay? Printf. When I have multiple statements in the block, then I must have the braces, okay? So here number is even. If R is not equal to 0, right? Not equal to 0. Then what do I say? Number is odd, right? Okay. We can see the program is ready. What we have done, we have declared two variables n and r. We have accepted a value in n, and then we have divided n with 2, and
Sir,
remainder we have obtained
sir,
in n. Yeah,
excuse me, sir. There, we should open bracket
yeah.
after it. If
If you want, you can have. Otherwise, also no issue, because there is only a single statement in if block, right? That is printf. If there is only one statement, braces are not required. Okay, but multiple statements are there, then of course it is required rather, right? So you can have or not, no issue, since there is only a single statement in it, right? Okay.
okay, sir.
Sir, can we apply this in division, sir?
Yes, division. Division, you will get quotient, right? We wanted to have
If
the remainder out of it. So for that we have to
like
use
if we,
mod up. Yeah. Tell me.
like if we like denominator shouldn't be zero, na, sir.
Acha, exceptions you want to add? No, we are the
Yes, sir.
logic behind is divide the number with 2, okay, and if the remainder is 0, it is even. If the remainder is 1, it is odd, right? What's the point? This is the logic.
Yes, sir.
Yeah, for that, what you have to do, you have to
Sir, I'm
first
not
divide.
telling in this.
Yes, tell me.
I'm telling in different programs, sir. I'm not telling in this one.
No, no, is this logic clear to all of you?
Yes,
Yes,
sir.
sir.
Yeah, this is odd even program. Okay, we'll first try to execute this after saving it. We'll save it first. We'll say odd even. Now execute the program. Here we have to choose the language before we go for execution. So say C here, then say run. So here you are asked to enter the number. Let us say, for example, you have given 16. Fine. It is even, right? 16 is even. Again, execute. Let us take value as 21. If I give 21, number is odd, right? So is that clear to all of you? Yes. Yeah, take some assignments here. Please note down some assignments here. Write a program to find the entered year is leap or not. How do you find whether the entered year is leap or not? You will have to divide it with 4. Okay. You have to divide, for example, 2000. Take 2020. Divide it with 4. 4 5s are 20. When you are taking 2 digits here, you have to insert a 0 in quotient. 4 5s are 20. Okay. So if the year is divisible by 4, then you say it is leap. Otherwise, it is not a leap year. Okay. So how do you write the program for it? Take a variable y to accept the year. Take a variable r to hold the remainder. Divide y with 4 and take the remainder in r. Then check the r value. If r equal to 0, you say it is leap. If r is not equal to 0, you say it is not a leap year. Yes? So can you do the program? What is the change you have to do?
Yes, sir.
Yes, you have to do a small change in this. Enter the year, you say
4.
y mod 4 here. If you are taking n, and also you can take variable, can be anything. Mod 4 you do, right? I hope you can do this, right? Okay, take another assignment here. You have to note down all this assignment. Write a program to find the greatest among two numbers. How do you find greatest among two numbers? You will have to compare. Take two variables a, b, read them. Yes. Then you will be comparing. If a is greater than b, what do you say? A is greater. If a is less than b, then what do you say? B is greater. Yes, sir. So can you write the program for the same?
Yes, sir.
Yeah. If you want, you can include another condition here. If a equal to b, then you say both are greater. Both are equal and greater. Okay. So you can have multiple conditions. No issue. Fine. So you can add these 3 conditions and write a program to find the greatest among two numbers, right? Take another assignment here. Write a program to find greatest among 3 numbers. Okay. So what do? You take 3 variables a, b, c. Here we need to include the logical operators as well, right? So I can say if A greater than B and A greater than C, then you say A is greater. Yes or no? In order to A to be greater, it should be greater than B and as well C. Okay. Similarly, B is greater than A and B is greater than C, then you say B is greater. If C is greater than A and C is greater than B, then you say C is greater. So taking these conditions, you can write the program to find greatest among three numbers. Yes. Can you do this? Yes. You can do it, right?
Yes, sir.
Yeah. Now, we'll write another program here. See, all these assignments which I am giving, you should write them neatly in A4 size papers, okay, and then upload the same in the classroom, giving the date of given and date of submission, and then the concerned programs you have to execute in the online GDB. The link of the same should be shared along with the assignment that you upload in the Google Classroom. Okay. I hope it is clear to all of you. In assignment itself, you will be giving the link of the online GDB, the program. When you have executed, you will get a link in URL. That link has to be shared in the Google Classroom along with your assignment. Okay, so that for that respective program, I can go and verify the same. Okay, so we'll see another program here. Write a program to find the roots of a quadratic equation. Roots of a quadratic equation. How do you find the roots of a quadratic equation? There will be two roots, right? Root 1 equal to minus b plus under root
B square.
minus 4ac by 2a. Another root is okay minus b minus under root b square minus 4ac by 2a. What is this b square minus 4ac?
Discriminant.
Discriminant.
Discriminant. If discriminant is 0, if discriminant is equal to 0, what do you mean by it?
Equal root.
Yes,
Real and equal.
roots are real and equal, right? And if discriminant is less than 0, roots are
Imaginary.
Imaginary and
yes, imaginary. So when the roots are imaginary, you cannot find the roots. It means you don't calculate root 1 and root 2. Yes or no? You just imagine. Imaginary means you just imagine. You don't get in real rather, right? Fine. Next is if discriminant is greater than 0. What do you mean by it? Roots are
Roots are
Distinct
imaginary.
real.
real and distinct, right? Okay. So we have to check these three conditions. Yes or no? So before you evaluate this, before you evaluate root 1, root 2, what is that you have to do? You will have to perform this comparisons, right? So to write the program for the same, how do you write the program? What are the variables required here? You just check the variables required are A, B, C, root 1, root 2, discriminant. Yes or no? These are the variables required. So what could be its type? ABC, ABC can be integer, but discriminant root 1, root 2. Discriminant, when ABC are integer, discriminant also will be integer. Yes or no? But root 1 and root 2 can be float here. Yes or no? So first you have to
Yes, sir.
identify. Yes. So this is called problem analysis, right? So in problem analysis, what is that you do is first you identify the variables, you identify what type of variables they are, and then what are the inputs in it, and then the logic behind it, then you print the output. Fine. So we got the logic here, we know the variables, and we know the type of it, right? And we know the inputs of the same, and we know what is the output. So we can write the program for the same. Yes or no? So here, before writing the program, if you have to write the algorithm, how do you write the algorithm? Algorithm roots. Roots quadratic expression, right? Quadratic. Then you say begin here. What are the variables to be declared? Int A, B, C, and then float.
R1, R2, and D.
Float 2 and root.
R1 and R2, right? Then what do? You read ABC, right? Read ABC. Then what do? You will calculate the discriminant first. Disc equal to B square minus 4AC. This is algorithm, so I need not to follow the language notations or the syntax. Okay, I can use some simple mnemonic codes or English kind. So I'm just writing disk equal to B square minus 4AC. Then I will check the disk, right? I need not to give the parentheses also if required. Okay, fine. In algorithm, you need not to follow syntax. Fine. If discriminant is less than 0, what do you say? Print roots are imaginary, right? Roots are okay. Then if disk is, let us say, equal to 0, what do you print? Roots are real and equal. Okay. If discriminant is greater than 0, that is the next statement I write here, right? If discriminant is greater than 0, then
Real and distinct roots.
yes. So I'll be having set of statements, so I can again start a block for it. You will have to evaluate and then print, right? So now you are going to evaluate root 1 equal to minus b plus under root. I can write under root also is an algorithm, rs in Python programming notation, if I have to write in C to find the square root, we have sqrt function, right? You can use sqrt also, no issue, right? Sqrt of what? Disk. Okay. Then y 2 into a. See, I should give it in parentheses. If I don't give in parentheses, what happens? This whole will be divided with 2 and a will be multiplied. But we don't want like that. We want 2 and a to be multiplied first, then it has to go as a divisor. For that, we need to give it in parentheses, right? So, root 2. Root 2 equal to minus b minus sqrt of disk by 2 into a. So now we are going to print saying that roots are real and distinct. And they are root 1, root 2, right? Terminate the block and then algorithm. This is the end of algorithm, right? Got it? This is how you write the algorithm. Then if I have to draw the flowchart for the same, how do I do it? Draw the flowchart for the same. Flowchart for whom? Roots of quadratic equation, right? Roots of quadratic flowchart. So first you start, you say start with oval, then you declare the variables a, b, c, disk, root 1, root 2, right? You have declared it. These as integers, these as float, right? Declaration, you do it with the help of rectangle, right?
Rectangle.
Yes. Then you read the inputs. What are the inputs here? A, B, and C, right? You have read the inputs A, B, C here. Then what do? You find the discriminant, right? This equal to B square minus 4AC. You represent it with the help of rectangle, right? Yes or no? B square minus 4AC. Then you are going to check the discriminant here, right? So if my flowchart does not suffice in the same page, I will be using a connector. So this is my connector here, A. Now I can move on to the next page. Then I can start with this connector. Here, what is that I have to check first? Disk is less than 0. If disk is less than 0, what is that you want to print? You want to print roots are imaginary. Yes or no? Roots are imaginary. Okay. If let us say this is false, when this is false, you check another condition here. Disk is equal to 0. Okay. Disk is equal to 0. Now, if discriminant is equal to 0, then what do you print here? You print roots are real and equal. Real and equal. Okay. Got it. Next one is if discriminant. If let's say this is false, then you will check discriminant is greater than 0. If it is greater than 0, then first you calculate root 1 equal to minus b plus sqrt of disk by 2 into a, right? Then root 2 equal to minus b minus b minus sqrt of disk by 2 into a. Then you print the same, yes or no? Print root 1 and root 2. This whole has to be represented in rectangle, yes or no? Because you are performing arithmetic logical operation. A print you can do it with the help of a parallelogram anyway. So this whole, when this is false, also you come on to the next statement or stop, right? When this condition is true after this, okay, though you check these conditions, but then you will come to the, you check the conditions and these all to be false, you then come to the end. Fine. If this false, then you again check the discriminant equal to 0. If this is true, then you print this. But then after that, you again check this condition, then you come to end, right? When it is found to be false. But when both of them are found to be false, then the third one is going to be checked. When it is found to be true, then what happens? You will be executing this, right? So I just terminate here. The rectangle. This part I wanted to show you with parallelogram, right? As print will present with parallelogram. It's an output, right? So after this, okay. So I hope this is clear to all of you.